University English 2, The Skills, is here once more, this time with Unit 5, Talking Numbers, or reading and using cardinals, ordinals, and Roman numerals, and then looking at how they're used in metric measurements and mathematical operations. We'll begin with our usual introduction, and then this will be followed by cardinal numbers. We'll take a look at some alternative forms of cardinal numbers also, and then how we can go about reading these numbers, and then we'll take a look at decimals. We'll move on then to ordinal numbers, look at the uses of ordinal numbers, how we form those ordinal numbers, and then their use in fractional numbers or fractions. Then we'll take a look at Roman numerals, the uses of Roman numerals, and how we can form them. Into metric measurements next, we'll be taking a look at base measurements, and then we'll have a look at SI prefixes, and then some readings for metric measurements. This will be followed by mathematical operations, functions and how you read them in English, followed by some readings. And finally, at the end, we will have a summary. Amy Kaufman and Jay Christoph in Illumini in 2015 said, "Numbers do not feel, do not bleed or weep or hope. They do not know bravery or sacrifice, love and allegiance. At the very apex of callousness, you will find only ones and zeros." Now, numbers are present in virtually every aspect of our lives. When you buy or sell something, when you call someone, when you look for an address, when you drive a car, when you think about the date today, and so on. There are numbers everywhere. Now, the use of numbers is really of crucial importance to all the professions, but particularly important for those related to the sciences, with mathematical terminology and the correct use of measurements being at the forefront of importance. Now, there are three important categories of numbers which we have in English, in order of their importance. The most crucial and commonly used are called cardinal numbers, and you might already be familiar with these, numbers such as 1 and 2. Of secondary importance are ordinal numbers, and these would include numbers like first and second. And then finally we have Roman numerals, which originate from the Latin world and are sometimes used as written numerals in place of the Arabic numerals which we commonly use today. Now, often errors occur in English readings of numbers, and this is usually not because the numbers themselves pose difficulty, but because they are often read in different ways in other languages, making it therefore quite confusing to understand how to read that number in English. As accurately actually making use of the variety and kinds of numbers in English is so important, these issues have to be actually tackled head on, and that's what we are going to do today. Let's begin then with cardinal numbers. Now, cardinal numbers, sometimes simply referred to as cardinals, are a means of counting using sets of natural numbers. The metric system is the most commonly used system today, and it is a decimal system, meaning that each cardinal set has 10 units within it. Commonly, outside of mathematics, smaller cardinals are written as words, and larger numbers are written as numerals. In mathematics, of course, they are always written as numerals, but when you're writing, then you should be writing smaller numbers as words, and larger numbers as numerals. Note that cardinal numbers can perform several different functions grammatically, so they can be determiners, making them part of a noun phrase, or they can be nouns or pronouns in their own right. So let's take a look at an example here. So person A says, could I order 10,000 masks? Now notice 10,000 is written as a numeral because it's a larger number. So this is the common practice here with larger numbers. In this case, 10,000 is acting as a determiner for the masks, telling you the quantity of masks. And then person B replies, I'm sorry, we don't even have 10. So in this case, 10 is a pronoun for the masks, meaning 10 masks. It's a smaller number. So now we are going to write that number as a word. Here is an illustration of how cardinal numbers will work. So starting from the top left then, we have the numeral and then the word for that numeral. So the first is 1, and then 2, 3, 4, 5, 6, 7, 8, 9, and 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. Now with the teens, you want to make sure when you're reading them that you're pronouncing the teen on the end. Otherwise they can be confused with a word which you can see in the start of the third column there, 31. So 30 is different from 13. So you want to make sure that you're pronouncing the teen and not the T in order to not to confuse the two. So starting from the third column, 31, 42, 53, 64, 75, 86, 97, and then we are up to 100. Now let's add 10 to 100 and we reach 1,000. Another 0 and we get to 10,000. Another 0, 100,000. Another 0, 1 million. One more and we have 10 million. And then up to 100 million. And then 1 billion. And now we're going to add 3 zeros to the end and perhaps vary the starting number for the sake of examples. And for after 1 billion, we then go to 2 trillion. And then we have 5 quadrillion, 6 quintillion, 8 sextillion, and 9 septillion. Now, if you're going to be able to read numbers, particularly larger numbers, you are going to need to know how to read numbers 1 to 999 accurately. So be aware of how to read the numbers 1 to 999 accurately, and then you need to learn the words for the additional blocks of 3. So of key importance here would be 1,000, and then million, and then billion, and then trillion, and then quadrillion, and then quintillion, and then sextillion, and then septillion. Now you might think that some of these numbers are too big to ever be used, but they are used, particularly if you're in the sciences. But even in the field of economics, for example, the gross domestic product of Korea is already in the quadrillions. Now there are some alternatives to the numbers that we commonly use. For example, 0, which is the more formal form, which is used in mathematics and sciences, actually has several alternatives as well. So let's take a look at some examples here. 0. Now this is commonly used in the United Kingdom, and the example 7 plus 0 equals 0. O because it looks like the letter O looks like the letter 0. So we can often use O in spoken language, and this is used in less formal spoken language. So the answer is 10.05 instead of 10.05. Now, nil is commonly used in British sports. For example, Chelsea won with a score of 1-0. And nothing is commonly used in American sports. The final score was 16-0. And then we have a variety of slang expressions as well. Zilch, for example. You know zilch. You know 0. You know nothing. Nada. I've got nada. Zip. They have zip to offer us. And nix. Whereas zilch, nada, and zip are generally nouns, nix is sometimes used as a verb as well. So we should nix it. We should make it 0. Now, in addition to the number 0 having alternatives, other numbers also have alternatives. Some alternatives are prefixes, meaning we add them to the start of lexems or base words to indicate a value. So the number 1, for example, also has prefixes here, uni or mono. For example, he always wore a monocle. A monocle would be glasses, except they're not glasses, it's just one of them. So you have one eyeglass, a monocle. 2, often referred to as couple, pair, or as a prefix, bi. For example, bicycle has 2 wheels. So they look like a nice couple. 3, trio, tri being the prefix. So tricycles are not well balanced. A tricycle is a bicycle with 3 wheels instead of 2. 4, quartet or quad as a prefix. I don't like quadratic equations. A quadratic equation then has 4 parts to it. 5, penta is a prefix, or quint is also a prefix. So they made a great quintet, a group of 5 musicians. 6, hex is a prefix and sex is also a prefix. So she had sextuplets would mean she had 6 children in one birthing. 7, hept is a prefix, sept is also a prefix. They competed in a heptathlon. That means there would be 7 events in this athletics competition. For 8, octo is a prefix. For example, he has a pet octopus, a sea creature with 8 tentacles. 9, non is a prefix. The chorus was made up of a nonette, so there were 9 singers in that group. And 10, dec, is a prefix. So the 1980s was a decade of music. So decade here meaning that 10-year period. 12, a very commonly used alternative, dozen. Can I have a dozen eggs, please? And you can also use half dozen, meaning 6. Can I have half a dozen eggs, please? 20, score. He has lived for only a score of years, meaning he's 20 years old. And for 100, cent is a prefix and hecto is another prefix. So the last century saw great changes. A century is a period then of 100 years. So let's talk about how we can go about reading and writing cardinal numbers. Now the numbers 1 to 19 are simply read as the word, and you just need to know what these numbers are. So I have written 5 reports today. put the quantifier before the noun as a determiner, telling you the quantity of the noun if you want to talk about the number of a noun. Derivatives of numbers 20 to 90 are read by attaching a number of between 1 to 10 after them. Now, when you're writing this as a word, you will use a hyphen, which will be inserted between the larger number and the smaller number. So, for example, here, there are 26 courses. Hundreds are read by reading 1 to 9, followed by the word hundred. 100, 200, 300, 400, and so on. Now then, any derivatives of 1 to 99 are read after the 100 reading. If there are no derivatives, smaller parts of 100, found after the 100 reading, then you don't need to read anything more. Note that British English usually adds and after a reading of 100. American English usually does not. Whether you choose to add and or not is up to you. But if English is your second language, it's probably easier not to try to add and in most cases, because it becomes more difficult to know where to add it. So let's look at an example. A says, doesn't the movie have 100 puppies in it? So you've just got 1, then 100 to quantify the 100. No, there are 101 puppies in the movie. Now, that would be me because I'm from the UK, but if you are American, you would probably have read that there are 101 puppies in the movie. Now, to read a number of 1,000 or more, first, if you haven't already done so, you want to take the numeral form that you've got and add a comma after every 3 numerals, starting from the right-hand side. And this is going to make it easier for you to read this number. For example, if you are given a number like this, it's going to be very difficult for you to read it unless you actually start adding the commas. So let's just add in a comma starting on the right-hand side after every 3 units here. So there we go. Let's add a comma in. And now we have a number which is actually much easier for us to read. Now look at the number from the right to the left. So again, looking at the right side first. And the first block of 3 units is 100 or smaller. The second block is 1,000, then million, billion, trillion, quadrillion, quintillion, sextillion, septillion. And then you identify them, which is which. So in this case, we've got 100 or less, and then 1,000, million, billion, trillion, quadrillion, quintillion. Okay, so we're starting with quintillion. And now we're in a position where we can read this number. So we've identified each block, and we now want to read the number from the left to the right, with each block being read in the same way as you would with numbers of less than 1,000. But also adding the name for the block as the final word for that 3-digit numeral. For the 100 or less category, just read the number without any final or additional word. When writing words, as with numerals, a comma is usually going to be added after each of these blocks, and this simply represents a pause when you are speaking. Now for British English, and is added before the final block where it is less than 100. And once again, this is not usually done in American English. So you can see that in the brackets we have ands here, which would all be read by a British English speaker, but unlikely to be read by an American English speaker. So I'm from the UK, so I'm going to read it as a British English speaker. So this number would then be read 101 quintillion, 499 quadrillion, 157 trillion, 387 billion, 275 million, 10,000, and 1. Let's take a look then at decimals. Now, decimal numbers or decimals are used to represent a part of a whole number. Decimal points can be written in words and spoken as point. Decimals are often used to show parts of 1. For example, this would be 10.7. Decimals can also be used to represent parts of larger numbers. For example, 3,500,000 could be read as 3.5 million. And they can be used to represent tenths of larger parts of numbers, because we operate a decimal system, remember? So in which case they are read only as individual units, not as a whole number. So this, for example, would be read as 1.37. Read the decimal places as individual units. Do not read it as 1.37. That's wrong. Now, 0, remember, is often referred to as O when we're speaking, particularly when it's used with decimal numbers. But remember that you're only writing it formally as 0 if you have to write the word out. So, for example, here, this number could be read as 1.304 or 1.304, but only if you're speaking it. A number of less than 1 starts with point or 0 point or O point, but only if spoken again. So in the example here, there are many ways this could be read. You can read it as 0.032 or 0.032 or 0.032, but only when you're speaking it, or 0.032 or 0.0, you can alternate between O and 0 as well, 32 or 0.032. So there are quite a few alternatives here. Let's take a look then at ordinal numbers next. Now, ordinal numbers, sometimes just called ordinals, are used to count position, rank, or order in a sequence. For example, William Cecil was the first Baron Burghley. Now, this would be then his position. She was ranked first in her school. This is her rank, clearly. They went to the movies first and the cafe second. This is order in a sequence. Now, ordinal numbers are also used as sequencing adverbs to order topics or events, in which case they actually take two possible forms. So one of the ways in which we change words to adverbs, particularly adjectives to adverbs, is to add the suffix ly. And we can also do that with these ordinal numbers. So you can say, first, I would like to discuss. And you can also say, firstly, I would like to discuss. So these are being used here as adverbs, in which case both of them have the same actual meaning. There's no real difference. It's just a matter of your choice for style. Now, ordinals are also used in dates. Often ordinal dates are represented as cardinal numbers with endings of ST, ND, RD, or TH. Now, in whichever way they are represented, they are always, and I mean always, read as an ordinal number. So dates will always be read as an ordinal number. So, for example, 1st of December, it's the 1st of December. And you can write that as 1 in a numeral form with a superscript ST after it. If you like, you can also write it in normal script as the second example is written. So 23rd of January, it's January the 23rd. And you can see a variety of ways that dates can be read here. So it's the 1st of December, or it's January the 23rd. Now notice that months when you're writing are often reduced to the first 3 letters of the month. So December here is just DEC, January is written in full. And in the last example, February 2, 2020, you still don't read it as February 2, 2020. You'll read that as it's February the 2nd, 2020. Now, as often seen with dates, when represented numerically, ordinal numbers will use cardinal number forms with the ST, ND, RD, or TH placed after them, either in normal case or in superscript. Note that the numbers 1, 2, and 3 are notably different between the cardinal form and the ordinal form. So 1 is a cardinal number. In an ordinal number, it becomes first. And the suffix or the ending that you want to add is an ST if you're using the numeral. So you would write that as 1 ST or normal script or superscript, as you can see in the examples. 2 becomes second as an ordinal number, the suffix being ND. 3 becomes third as an ordinal number, and the suffix is RD. So these 3 are notably different, and you need to make sure that you know first, second, third. Now, ordinals 4 to 19 are similar in form to their cardinals, well, with the addition and possibly note some spelling changes of TH for the ordinal. So these are going to take now TH. So 5 is the cardinal number. Notice that as with spelling conventions, V often changes to F in some cases when it's being morphed or changed. So 5 becomes fifth as an ordinal, and it's a TH ending. 11 becomes 11th, just add TH on the end. 19 becomes 19th. Now, with any larger ordinals, the number is read as a cardinal number with an ordinal ending. So the essential principle is that numbers ending in 1, 2, or 3 will end with first, second, or third, and other numbers end with TH endings. So you need to be able to pronounce that TH, by the way, the endings. So 0, for example, would become zeroth. Sometimes a schwa vowel is inserted in place of the last vowel. Zeroth. 112 would become 100, so you're reading it as a cardinal number. And then the last part you'll read as 12th. 112th if you're American, 112th if you're a British English speaker. 993 would become 993rd. Let's take a look at some examples here. So starting on the top left, 1 becomes first, and you can see the spelling and the numeral form. I've provided here examples of normal script for the STNDRDTHs and also superscript. Both are acceptable, by the way, so it doesn't really matter which ones you choose. So you've got first, second, third, and then fourth and fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, and 20th. And then for some, as examples for some larger numbers, it would then be, you're just reading the last part here. So 30, 1st, 40, 2nd, 50, 3rd, 60, 4th, 70, 5th, 80, 6th, 90, 7th, and 100th. 1000 and 1st, or 1001st if you're an American speaker. And then 7000 and 11th. So you need to know 1 through to 20, 1 through to 19, really, because these are the ones that are being added to the endings of other words if you are reading larger numbers. Now, another way in which we use ordinal numbers is for fractional numbers or fractions. Now, these are read as a cardinal number over an ordinal number. The reason for using the ordinal number is to make it immediately recognizable that this is a fraction. So if I said, for example, 1/3, then the person I'm talking to probably wouldn't understand. He might say, what, 1.3 or 13? What exactly do you mean? But if I say 1/3, then they will immediately know that I'm talking about a fractional number, and that's why it's read in this way. So the first example is literally 1/3. That's one way of reading it, or 1/3, a third. Now remember that literally is a determiner meaning one amongst many. It literally means one. So you could replace 1/3 with a third as well. Now note that some fractions actually have alternative readings as well. So this could be read as 1/4, which is a little bit long, which is why we'll read it as 1/4. So cardinal over ordinal number. But you can also read it as a fourth, remember a meaning one, or 1/4, or a quarter. Now there's one fraction which cannot be read as a cardinal over an ordinal number. And the reason for this is it would cause confusion, because the word second is also a unit of time. So in the example here, if I say 1 second, then you might think I'm literally saying 1 second. And this is actually a common expression when you're asking people to wait. You'll say, oh, 1 second, meaning, can you wait just a little bit, please? So it would be very much confused. And the reason we are using a cardinal over an ordinal number is for clarity, so that we can be clear. So this is not read as 1 second. Instead, it's read as 1/2 or a half. Now note that plural fractions, plural means not equal to 1. So 1 is singular, anything not equal to 1 is a plural. So plural fractions are read and written with a plural ordinal number. For example, 4 is not 1, it's greater than 1 in this case. So this would not be read as 4/7. No. There are 4 of them, so it has to be 4/7. And this is quite difficult to pronounce for a lot of people. So now you have to have the th with a s on the end. So 4/7. So perhaps you should practice that. Now when reading a whole number with a fractional number, and is added after the whole number. And this is to distinguish the numbers. So this would be read as 4 and 3/10. Otherwise, it would be 4 3/10. It would cause confusion. That's why we add and in this case in British and American English. So 4 and 3/10 because it's a plural fraction. Let's move on to Roman numerals. Now, Roman numerals were commonly used in Europe until they were replaced by the Arabic numerals, which are now commonly used, but this occurred in about the 15th century or so. Now, Roman numerals are still found in use today in legal documents, on clocks, on buildings and monuments, on title screens in movies and TV shows, and in page numbering and birth order. For example, here we have a famous king from the Tudor dynasty in England, King Henry VIII. So it will be read actually, as you can see, as an ordinal number, but we're using a Roman numeral in order to show the number is 8, and this will be read as Henry VIII. You might also notice that I'm using Roman numerals in these slides here. So you can see Roman numerals 1 is the title at the top, and we are soon to progress to Roman numerals 2. Now, there are 7 Roman numerals, and these are based on Latin letters, the old Roman language of Latin. Remember that the written form of English came from the written form of the Romans, and that's, in fact, many of the European languages use still Latin script, and that's why we call it Roman script still, because we never actually created our own language. We just took the old Roman language and made it work for us. So we're going to be using these Roman numerals for the Roman numerals Latin letters. So you can see actually that these can be used in uppercase, meaning capital letters, or in lowercase. Usually they're used in uppercase, but they can be done in both. And these, if you want to be able to read Roman numerals, you need to learn these actual 7 numerals which are being used for numbers. So let's take a look at cardinals. So 1 is the letter I. 5 is the letter V. 10 is the letter X. 50 is the letter L. 100 is the letter C. And 500 is the letter D. 1000 is the letter M. Now, in order to form a Roman numeral, we put a larger numeral and then place smaller numerals either behind it, meaning minus, or in front of it, meaning plus. So if I wanted to make the number 2, in this case, we can use II because they are the same number, and so they will add together. So II is 2, 1 plus 1. For the number 7, I would start with 5, which is V, and then I want to add 1 and add 1 again. So I will have VII. For the number 40, I will take the number 50, which is L, and I want to minus 10 from this number. So in order to minus, I will put it behind. I will put the X, which is 10, behind the L. That means 50 minus 10, so this is 40. Now, to make larger Roman numerals, the largest units with their additions or subtractions will go first, followed by other smaller groupings. So if I want to make the number 12, I will have 10 plus 1 plus 1, which would be XII. For 83, I will have 50, which is L, and then I will add 10 and 10 and 10. So L, X, 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 and then I will add 1 and 1 and 1. L, X, 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 I. For 345, I will add 100 to 100 to 100. Then I will make 40. And to make 40, I will subtract 10 from 50, which is XL. And then I will add 5, which is V. So that would be CCC XL V. Now, Roman numerals will always group in a maximum of 3 numerals adding to the previous larger numeral before any subtraction occurs. Also, as it's a decimal system, the Romans also used a decimal system, 10-unit based system. Subtractions always occur in tenths of the current decimal unit, which means that for the number 99, we must subtract 10, which is 1/10 of the current decimal unit, which will add up to 100. So 1/10, not 1 from 100. So I cannot subtract 1 simply from 100 because that is a unit of 100th. And we are working in units of 10, not in units of 100. Similarly, for the number 49, we would subtract 10 from 50, as we are already in tenths of 100. The final 9 for both of the latter cases would then be 10 minus 1. So in order to get the number 9 then, as we're working in a decimal system, I would simply subtract 1 from 10, 1/10 of that. So this becomes IX. For 94, I would have to subtract 1/10 from 100. So that means I need to go to 90 first. So 90 would be C minus X, which would be then XC. And then in order to get 4, I will subtract 1 from 5, which is IV. So that would be XC IV, 94. Now, Roman numerals are often used for dates. So let's take a year, 1949. So how would we create this as a Roman numeral? Well, we need 1000 first. And then for the 900, we need 1000 minus 100, which is 1/10 of that unit. So that is then M for the 1000 and then CM for the 900. And then I need 40, which is once again 50 minus 10, so XL. And then I need 9, which is 10 minus 1, IX. So MCM, XL, IX. Now, for very large numbers, you can use parentheses. And you can, if you're speaking, you can simply, often we call parentheses brackets as well. So when speaking, you might say open bracket and then close bracket after you've finished. And these parentheses are used to multiply the Roman numeral by a factor of 1000. So if I want to make 5000, I can take V, which is 5, and I can multiply it by 1000, making it 5000, by putting it in brackets, putting it in parentheses. So this would be read as open brackets, V, close brackets. Similarly, X in parentheses, which is 10, would mean 10,000, and M in parentheses would mean 1 million. Here are some examples then of Roman numerals and their corresponding cardinals. So 1 is I, 2 is II, 3 III, 4 IV, 5 V, 6 VI, 7 VII, 8 VIII. Now remember, you can only have 3 units adding maximum. So for 9, I cannot have VIII because that's 4 units adding. 3 units adding is maximum, which means to make 9, I must actually have IX. 10, X. 14 would be XIV, 15, XV, 18, XV, III, 19, X, and then IX for the 9, 20, XX, 23, XXIII, 34, XXXIV, 45, X, and then I will have L, and that's the 40, and then V is the 5. 56, LVI. 67, L, 50, X, 60, V, 5, II, 7. 78, LXX, VIII, 89, L, 50, X, 60, X, 70, X, 80, and then for the 9, IX. 103, so C is 100, and then 3 after that, C, III. 259, well, let's have CC, and that's 200, L is 50, and then IX is the 9. 445. So now I will take 500, which is D, and I will subtract 100 from that 500. So that becomes CD, and that's 400. And then I need 40, which is XL, and then I need the 5, which is V. For 833, I will have D, 500, CCC, that's 800, XXX, that's 30, and III, that's 3. Now 2,999, let's get the 2,000 first. That would be MM, 1,000, 1,000, that's 2,000. Then, as it's a decimal system, I need to subtract 100 from the 1,000, 1/10. So that would be CM, and that's 900. And then I need 90, which would be 10 minus from the 100, so XC, and then 9IX. 8,567. Now we're looking at larger numbers, and in this case now I need to use brackets, parentheses, to multiply. So in order to get 5,000, I need actually to multiply V by 1,000. So open bracket, V, close bracket, that's 5,000. MMM, 8,000. D, 8,500. L, 8,550, X, 8,560, and then VII, 7. 10,100, well, I can just multiply 10 by 1,000. So open brackets X, close brackets C. 2,400,492. So this is a little bit trickier. I need to have the millions and the 400,000s as well. So I'll open bracket and have MM. That gives me 2 million. And then for the 400,000, CD. And then close bracket. So that's 2,400,000. Now I just need 492. So CD gives me 400. And then 90, XC, and then 2, II. Let's take a look at some applications of numbers, and we will begin by looking at metric measurements. Now, the metric system dates back to the French Revolution, which was between 1789 and 1799. And this actually provided an opportunity for the French to transform what was a very awkward and complex system of weights and measurements into a newer form. Now today, an updated metric system is commonly used around the world. There are some exceptions, those being the United States and a few Caribbean islands, which still use the imperial system, which was originally developed by the British. Now, the metric system is the International System of Units, and it is abbreviated to simply SI, and it comes from originally the French, Système International de Unité. Now, the SI uses 7 base physical quantities for a variety of measurements. For length, the base unit is the metre. The spelling is M-E-T-R-E for British English, by the way, M-E-T-E-R for American English. The symbol is small case, and the difference between small and big case is important in this case. So a lowercase or small letter m. And the defining constant is the speed of light. For mass, the base unit is the kilogram, and that's written in small case kg. The defining constant is the Planck constant. For time, the base unit is the second, and the symbol is small case s. And this is defined as the hyperfine splitting in cesium-133. For temperature, the base unit is Kelvin, and that's an uppercase or a large capital letter K. And the defining constant is the Boltzmann constant. Electric current has the ampere as the base unit, capital A. And the defining constant is the elementary charge. For amount, the unit is the mole, and the symbol is small case MOL, and this is defined as the Avogadro constant. Luminous intensity, the base unit is the candela, and this is written as small case CD, and the defining constant is the luminous efficacy of 540 terahertz of KCD. Now, there are many prefixes which can be used before numbers in order to create measurements with the SI. So we have base units, and then we will put this before the base unit as a word or a symbol in order to tell us the quantity. And you're probably familiar with some of these terms. For example, hard drives are usually measured in gigabytes or terabytes these days. So let's take a look at some of these. Tera, the symbol is a big T, and this is 10 to the power of 12. Giga is a big G, and this is 10 to the power of 9. Mega, a big M, 10 to the power of 6. Kilo, K, small k this time, is 10 to the power of 3. Hecto, small h, is 10 to the power of 2. And deca is 10 to the power of 1. There is nothing for just 10, or 1 actually. It's a factor of 1 now. Now, if you want to go to smaller units, and you're probably familiar with these prefixes as well. For example, deci, a small d, is 10 to the power of minus 1. Centi, as in centimeter, would be a small c, 10 to the power of minus 2. Milli, small m, is 10 to the power of minus 3. Micro, and this is a U with a line on the left side going down as well, would be 10 to the power of minus 6. And nano is a small n, 10 to the power of minus 9. And pico is 10 to the power of minus 12. Let's take a look at these different metric measurements and how we would use them in English. So the base measurement for length is the meter. 1 meter, and just notice that this is a slight difference in spelling between British and American English. This is about the length of an average guitar, and I'm sure all of you know the length of a meter. Now, common multiples and submultiples of the meter are the kilometre, which would be 1,000 metres, and the centimetre, which would be 1/100th of a metre, and the millimetre, which would be 1/1000th of a metre. Note that plurals, numbers which are not equal to 1, will add a final s, meaning that metre itself is a count noun. We can count it. However, when we write a symbol, we do not add s to the written symbol. So we would write 1000m, not 1000ms. Now, usually there is a space between the numerical value and the symbol, usually. So here, for example, he ran 100 meters. Now, this is not equal to 1, so it's going to be meters with an S, in under 10 seconds. Or he ran 100 m in under 10 s. Those would be the numerical forms. But when we read it, we'd still read he ran 100 meters in under 10 seconds. The SI for area is the square meter. It can also be called meters squared. So this would be written as m with a superscript 2. And the SI for volume is the cubic meter and can be read as meters cubed. And this will be m with a superscript 3. However, for volume, we also use the litre, and this is a capital L. Litre, and the spelling might be different between British and American English again here, is also a count noun. So with 1 litre is approximately equal to a carton of milk. So 1 litre equals 1 millimetre cubed. Here are some examples. The area of this circle is 1.5 meters squared. So to the power of 2 can also be read as squared. The volume of this sphere is 1 millimeter cubed, which would be 1 small mm with to the power of 3. I bought 2 litres of milk at the store. Now, the base unit for mass is the kilogram, written as a small kg. 1 kilogram is about the weight of a pineapple. Now, common multiples and submultiples of the kilogram are the gram. So 1 gram is equal to 1/1000th of a kilogram. And the ton, the metric ton here. So 1 ton, it's a small t, equals 1,000 kilograms. Now, kilo is a short form of kilogram. So you can just say kilo. I weigh 80 kilos without saying kilograms. So kilo is often used as a short form. Now, again, both of these words are count nouns. So if they're not equal to 1, you need to be adding an s. Again, not an s to the symbol, but you're adding an s when you're reading it, regardless of if you're using the word or the symbol. So as examples here, he lifted 100 kilos. I weigh 80 kilograms. Now, in the field of physics, note that mass is not the same as weight. However, outside of the sciences, it is roughly accurate to say that 1 litre of water, at least at the melting point of ice and at normal atmospheric pressure, which would be 1 bar for pressure, is equal to 1 kilogram. Now, the standard measurement for time is the second. In slang, note that we often use the word sec. Both of these words are count nouns. So you could say, for example, he ate the meal in 10 seconds. 1 second, 10 seconds. I will be there in a sec. meaning I will be there in 1 second, meaning 1 again here. Now, of course, there are other units for time, but some of them do not have SI symbols for them. Let's take a look. So a minute, this is 60 seconds, and the SI symbol for this is MIN in small case. Hour, this is 60 minutes, and the SI symbol is a small h. For day, this would be 24 hours, and the SI symbol is a small case d. For a week, this would be 7 days, but there is no SI symbol for this. And also for a month, some months are 30 days, some months 31, and some even less than that. So there is no SI symbol. For year, this is approximately 365.25 days. There is an SI symbol, and this is A, as in anno from the Latin, meaning year. And then for a decade, which is a period of 10 years, there is no SI symbol. A century is a period of 100 years. There is no SI symbol. And a millennium is a period of 1,000 years. And again, there is no SI symbol here. Now, often other units are measured in terms of time, but they can also be measured in terms of other things as well. In these cases, we place a / to indicate per, and it will be read as per, meaning every. So as examples, they were driving at 100 kilometers per hour, and you can see it would be 100 space small case km / h to represent that if you're using symbols. The element was putting out 1,000 joules per kilogram. So here we have 1,000 space, joules is a capital J, and then / kg. Now, the standard unit for temperature is the Kelvin, and this is represented as an uppercase or capital K. 1 Kelvin is equal to the temperature at which water can exist in all 3 states, gas, liquid, and solid. However, outside of the field of the sciences, people don't really use Kelvin. It's mostly used for the sciences. People will commonly instead, at least in the metric world, use Celsius. And this is a capital. Notice it's with a capital C, and it will be often shown with a little 0 in superscript before the big letter C. Now, unlike most other units, both Kelvin and Celsius are non-count nouns. So there are no plural forms. So you're not adding S. Celsius already ends in an S, that's possibly why. And for Kelvin as well, we don't add an S here. However, that little superscript 0 is read as degree, and this is a count noun. So you might say, for example, 0 degrees Celsius is when water turns into ice. 1 Kelvin is minus 253 degrees Celsius. Electric current is the rate of flow of electric charge past a particular point. Now, the unit of measurement is the ampere, represented as a capital A. Sometimes it's simply shortened to amp, and both of these are count nouns. So 1 ampere at 110 volts or voltage is typically enough power, is enough current to power a standard light bulb. So for example here, the unit was reading 1.5 amps. So we can count amp as well, and we're going to add the S because it's not equal to 1. Now, there are a number of other units related to electricity, all of them being count nouns. For example, voltage. This is the work required to move a charge from a location to another. And the unit is volt, 1 volt, 2 volts, symbol capital V. For power, this is the work required to move electrons through a circuit, multiplied by the number of electrons per second. And this is, the unit is the watt, capital W. And then for resistance, this is the opposition to the flow of current in a circuit, and the unit is the ohm. Now, the relationship between the voltage, the resistance, and the current, V equals IR, is otherwise known as Ohm's law. The amount of a substance is quantified by moles. The term originates actually from the word molecule. The mole of a substance is defined as the mass of a substance containing the same number of fundamental units as there are atoms in exactly 12 grams of 12C. At the moment, the best estimate of the mass of 12 grams of 12 carbon is 6.022 times 1023 atoms. And this number is known as Avogadro's constant, and the representation of this is the capital symbols Na. The mole is therefore the gram atomic weight of a substance, and this is a count noun. So, for example, calculate the number of moles from the atomic weight and the mass. Brightness is measured in candle power or candela. Roughly speaking, 1 candela is equal to the brightness of a standard candle. However, we also use another unit for brightness, and this is the lumen, small lm. A lumen is a unit of luminous flux that is equal to the amount of light given out through a solid angle by a source of 1 candela of intensity, radiating equally in all directions. Now, both candela and lumen are count nouns, so be adding the s if it's not equal to 1. So the light emits 1,500 lumens. Let's talk about mathematics now. Now, there are many situations where you may be required to read a mathematical problem out loud. And there are many synonyms for the most common mathematical functions. A few of them actually I've placed below, and next to them I've put how they would generally be voiced in English. So starting from the top left, this is read as plus, and then below that, minus. Next one is plus or minus, times or multiplied by, divided by or over, equals, or you can sometimes just say is, because the be verb means equals, is approximately equal to, is equivalent to, is not equal to. And then on the third column of symbols, there is to the ratio of, f or function, f dash or derivative, f double dash or second derivative, f triple dash or third derivative, f4 or fourth derivative, partial derivative or delta, integral, sum. Now, there are quite a lot of these, so let's go through some more here. So starting top left again, is greater than, is less than, is equal to or greater than, is equal to or less than, is not greater than, is not less than, is perpendicular to, is parallel to, is not equivalent to, is not similar to. And then from the third column, log. Log to the base 2 of x. Therefore, because, gives to or leads to or approaches. And we've already seen this one when you're comparing numbers. Per is an element of, is not an element of, contained in, a proper subset of, contained in, or a subset of. So from the top left again here, so superscript 2, as in to the power of 2, and notice that you can actually say this is to the power of 2, as you'll see in a bit. It can also be read in that way, but more commonly we just say squared. And then the next is cubed. And then from 4 onwards, we usually say to the power of 4. And then for the next, to the nth, or to the power of n. To the square root of, to the cube root of, to the fourth root of, factorial, percent, infinity, varies as or is proportional to. And then to the third column now, intersection, union, for all, cos x or cosine x, sine x, tangent x, cosec x, sine x, cosh x, tan x, mod x or modulus x. Now let's take a look at how simple arithmetic would be read. So this here you would read as 42 plus 24 equals 66. Now, similarly, a simple formula, here this is obviously the area of a circle, would be fairly easy to read. So this would be read as A equals pi r squared. However, reading a more complex formula can present a few difficulties, especially if you don't know the English for the symbols that you're reading. So this is a quadratic equation, for example, not an incredibly difficult formula, but it still poses difficulty in English. So this is how this would be read. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. Let's summarize. Cardinal numbers are the most commonly used numbers today. If you want to be able to read cardinal numbers, you must be able to read the numbers 1 to 999 if you're going to have any hope of reading a larger number than that. To read cardinals higher than 999, you need to know the words for higher groupings of 3, and those would be 1,000, million, billion, trillion, quadrillion, quintillion, sextillion, septillion, and higher if you're working with higher numbers. Now, ordinal numbers, first, second, third, for example, are most used for dates, and also they're used for fractional readings. To make the ordinals, remember that 1, 2, and 3 are quite different, first, second, third. The others generally just have a th or th ending. Read larger numbers as cardinal numbers and then put an ordinal ending of between 1 and 19 on the end, or if it doesn't have a number of 1 to 19 on the end, then just add a th sound to the end. Now, Roman numerals are still in use today, so it's important to understand which ones represent which numbers. So I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. The metric system allows us to quantify things around us with both words and with symbols. Most of these words are count, meaning you need to add S to the endings when it's not equal to 1, but the symbols are not. And by the way, you might wonder why I say plural is not equal to 1 rather than plural means greater than 1. It's because it's not equal to 1. For example, if I have the number 0.1 and I want to add kilogram to the end, 0.1 kilograms. This is actually less than 1, but it's still going to have the S. It's still going to count as a plural. So plurals are anything which is not equal to 1. You want to be adding the S, unless it's the few exceptions, which are non-count nouns. Now, to read mathematical operations in English, you need to know the English terminology for the operations. So particularly with operations that you will use related to your work, you must make sure that you know the English readings for these operations. And that concludes today's lecture on numbers. Thank you very much for your attention once again, and I'll see you next time.